Hey algebra students, tonight's video is over literal equations. What the heck is a literal equation? A literal equation example would be D equals RT. I've got an equation with multiple variables. I don't just have one variable x, I have three different variables. So I'm going to take this equation that stands for things. It stands for distance equals rate times time. Okay? Distance equals rate times time. If you have not already used this equation in science or something, it will probably come in handy soon. So this formula is already solved for D, but let's suppose I don't want to know the distance of something. I already know the distance of it, but instead I'm looking for the time. So now I need to take this same equation, but I need to solve it for what T equals. Well, how do I do that? How do I get T alone? You follow all the same steps that we've learned the last couple weeks to do that. So I see that r is being multiplied by t. To undo that, I need to divide each side by r. So I get my r's to cancel, and I see that t equals distance divided by rate. T equals d divided by r. So what we're going to be doing is taking these literal equations, these four examples we're going to do, and solve them for the variable that they ask us to solve for. So here I'm given the equation f equals 9/5 c plus 32, but I want to solve it for C. So this is the equation, the formula for Fahrenheit and Celsius conversions. So I'm going to take this equation where they've already figured out what F is, but I want to know what C is, okay? So to do that, I need to get C alone. We're going to follow the exact same process we've been doing to get C alone. I would first need to subtract 32 from each side. Well, F and a constant, 32, are not the same. They are not like terms. So I can't combine those. So all I can write is f minus 32. And then I have 9/5 c. Well, now how do I get c alone? We know how to do this. We multiply each side by the reciprocal, 5/9. My 5's cancel, my 9's cancel, and I see that c equals 5/9 times f minus 32. Now you could take that a step further if you wanted to and distribute in your 5/9. But we've got C alone. That's what they asked us to do. So I think we could stop just right there. Let's look at the next one. M divided by n equals p minus 6. And we want to solve for n. So right now, n is on the bottom. How do I get n to be out of the denominator of the fraction? We've gone over this before. We have to multiply each side by n. When I do that, my n's cancel, and I have m equals n times p minus 6. Okay, now you have a couple options. You could distribute in the n right here, okay, or I could see that n is being multiplied by p minus 6, that whole quantity. If I want to get n alone, I undo multiplication with division. So I'm going to divide each side by p minus 6. And I can do that because the p minus 6 was in parentheses together. So I have n equals m divided by p minus 6. I've gotten n alone, which is what they asked me to do in the problem. So I've done all I can do. Notice how we're not getting a single answer here, like n equals 6. That's not what happens when we have literal equations. The next one, I'm wanting to solve for v squared. M equals 2e divided by v squared. Again, my v squared is in the denominator, so I need to get it out of the denominator by multiplying each side by v squared. My v squareds cancel. I have v squared m equals 2e. I'm trying to get v squared alone. V squared right now is being multiplied by m, so I do the opposite and divide by m. My m's cancel, and I'm left with v squared equals 2e divided by m. That's as far as you can take it, guys, because you can't actually do that division. They're not numbers, they're variables, and so that's as much as we can do. They asked us to get v squared alone. That's what we did. We're done. The next one, e equals f plus g plus h divided by 7, and we're wanting to get h alone. So first, before I can get this h alone, I see that this dividing by 7's in the way. How do we get rid of dividing by 7? We multiply each side by 7. So we have 7e equals, now my 7's cancel, which is just what I wanted, and I get f plus g plus h. I'm wanting to get h alone. I see that f plus g plus h. I need to move my f over. It's a positive f, So I do that by subtracting. I have 7e minus f equals g plus h. I've almost got h alone. The g is positive, so I do the opposite and I subtract. I have 7e minus f minus g. Are any of those like terms? Heavens no, they're all different variables, so they're not like terms. I can't combine them. My g and negative g cancel, so I have h equals 7e minus f minus g. Looks like a really weird answer, but since they're all different and cannot be combined, that's as far as we can go. So there's 4 examples of how we solve literal equations. We'll practice more in class.